am going to discuss about normal derivative and directional derivative. Let's assume a surface equation phi equals c. If we differentiate this equation, we will get d phi equals 0. Now we know that d phi equals nabla phi dot dr, where dr is any vector in the tangential direction at any point P on the surface. Since d phi equals 0, we can write nabla phi dot dr equals 0. The dot product of two non-zero vectors is 0 implies that these two vectors are perpendicular to each other. So we can write delta phi is perpendicular to dr, and we can write nabla phi equals mod nabla phi n cap. Now let's define normal derivative. Normal derivative of scalar point function phi is defined as rate of change of scalar point function phi in normal direction. Mathematically, the normal derivative can be written as del phi upon del n, which equals limit delta n tends to 0 delta phi upon delta n. Now let's define the directional derivative. Directional derivative of any scalar point function phi along the direction of vector d is defined as del phi upon del d equals limit delta d tends to 0 delta phi upon delta d. We can establish a relation between delta n and delta d as delta n equals vector delta d dot n cap, which equals delta d multiplied by dot product of d cap and n cap. We can write del phi upon del d equals limit delta d tends to 0 delta phi upon delta d, which equals limit delta n tends to 0 delta phi upon delta n divided by dot product of d cap and n cap. Here we change the variable delta d to delta n. This equals to limit delta n tends to 0 delta phi upon delta n multiplied by the dot product of n cap dot d cap. Since delta phi upon delta n with limit delta n tends to 0 is del phi upon del n, and with the unit vector n cap, this will be equal to nabla phi. So this expression can be written as nabla phi dot d cap. So we derived that directional derivative of phi is equal to nabla phi dot d cap. Hence, the directional derivative is the dot product of gradient with the unit vector along the direction of vector d. With this discussion, I am ending this video. Thank you for watching.